you guys get yesterday's slide? Oh. Let's start. I know yesterday I promised that we will do confirmatory factor analysis, but I found this slide that on structural equation modeling, and I think that will be a better topic because this topic combine what we will call regression analysis and confirmatory factor analysis together. Then I say, let's present this slide because one of the topics that we will see during the presentation will be confirmatory factor analysis. We will be talking about it. But I wanted to start with this. I think it's a nice combination in what you are seeing in the class, because in the class you study multivariate technique. This is one of the multivariate technique. It's a different approach what we saw in explanatory or the factor analysis or principal component. Principal component in factor analysis, this is what I call data reduction tools that we have. Remember the explanation, we have a bunch of variables, too many variables. We want to see if we can reduce them in some way, in some latent, in some construct that we call factors in factor analysis, and we call them dimension when we are doing principal component. I have 50 variables, and I'm saying what is the underlying structure of these 50 variables? Can I reduce them, combining some of them, and create some construct, and come up with this construct I will call factors if I'm doing factor analysis or dimension. This same construct, it's why we call them latent construct. In structural equation, they're called latent variable. Then this is the way, but structural equation modeling is different. It's not me mining the data and come up with the construct. Structural equation modeling means I already have the model, the structure in my mind, and I'm trying to see if my data fit the structure. From the theory, I know a priori, what is my model, what the model look like, what are the relationship between the variables based on the theory in my field. Then I can test this theory in order to see if it fit the data that I have in here. This is what a structural equation model look like. My objective is at the end of the talk, if you see something like that, you will know what that means. That is my objective. Is This technique has this visual tool that you can see your actual model and the estimation of the model, but I don't expect you to understand right now, but you should be able to see this and understand what's going on there after the talk. It's a multivariate technique. It is used for theory testing. We are in hypothesis testing. It's not mining the data. We already know from the theory what are the relationships. We have the model in mind, and we're trying to see if this model fits the data that we have in here. Then that reminds a lot of what we learned about a system of equation, because now these techniques go beyond regression analysis. You can have more than one dependent variable. Then you are at the end resolving a system of equation that describe relationship between the variables. Some advantages we have with this technique is we can incorporate confirmatory factor analysis into it. When we incorporate confirmatory factor analysis, what that means, we assume that the variables are measured with error, not